Okay, we are doing similarity notes 1. So our first thing we're talking about is dilations. When we talk about dilations, it is a type of transformation that takes the image and makes it different. Like either it's going to get smaller or bigger. So we say like an enlargement, which is expanded, or a reducement, which was contracted. So in this example here, our pre-image is our triangle ABC. And when we talked about transformations in the very first unit, you'll remember that our image has A prime, B prime, and C prime. So our pre-image doesn't have the primes and our images do. And then it says, is a dilation an isometry and why? So remember, if we're talking about an isometric, we want it to be the same shape and size. With dilations, that is not always true, because obviously they're not the same size. So we would say no, triangles are not congruent. So if you were to be asked, like, what type of transformations are isometric, a dilation would not be part of that. And then it says, in a dilation, a figure is enlarged. I kind of already went over this, so it's either expanded or reduced with respect to a fixed point called the center of dilation. In this example, and in a lot of our examples, our origin is going to be our center of dilation. So it's not always that way, but we're always looking at a center of dilation. And then to figure out how much our shape is changing, we use something called a scale factor. We use this letter K to represent that. And the scale factor is a ratio that compares the distance from the center of dilation to the image, and then the distance from the center of dilation to the pre-image. So if it's to the image, that's like P prime, and the pre-image is just P. So if K is less than 1, it's a reduction. Basically, if you're multiplying the triangle by anything less than 1, it's going to get smaller. So it started here, and then it got smaller. It was a reduction. If it is greater than 1, it's an enlargement. So basically, if you're multiplying it by anything bigger than 1, it's going to get bigger. And then, so we're actually going to look at an example now. It says, so what actually happens when a shape is dilated? So we're going to compare our sides. A prime, B prime is 12. AB is 4. Can we simplify that? Yes, we get 3 over 1. A prime, C prime is 15. AC is 5. Can we simplify that? Yes, 3 over 1. B prime, C prime is 16.5. And BC is 5.5. That simplifies to 3 over 1. So now it says sides are blank. That's where we're going to put that they are proportional. They all changed by a scale of 3 over 1. So if this scale is the same each time, they are proportional. And then we compare the angles. So we can say angle A is congruent to A prime. Angle B is congruent to B prime. And angle C is congruent to C prime. So our angles are congruent. And then we go to the next page. Dilation properties. Angle measures. The angles must stay the same. Parallelism. Things that were parallel remain parallel. So if there was 2 lines that were parallel, when we do a dilation, they must remain parallel. Collinearity. Points are on a line. They remain on a line. So we're not going to be changing any of our points. They need to stay on a line. Distance is not preserved. The distance are proportional. So it's not always going to be the same side. It's going to change, but you need to make sure that you're changing it proportionally. So if we look here, notation first. It says this here is our dilation. This is our center. And then we put our scale factor of x, y. So here, if I want to find my scale factor, I do the prime over my preimage. So c to p prime is 5 over 10, so it gets simplified to 1/2. Is it a reduction or an enlargement? This one would be a reduction because it's under 1. Do the same thing here. My scale factor is p prime over p, so plug that in. I get 15 over 7, and that is an enlargement. It's bigger than 1. Then it says determine on the next few ones if it's an enlargement or a reduction. So if I look at this first one, I can say, oh, scale factor of 5 over 2, that is bigger than 1. Enlargement. This one is going, the prime is closer to the center, so that's a reduction. This one, the scale factor is 5. If you can't see that, it's 5. So that's an enlargement, bigger than 1. Here, the prime is further away from the center, so it's an enlargement. 0.5 is our scale factor, so that is a reduction. And then 2 over 3 is less than 1, that's a reduction. And we are not going to do these parts today. Let me see if there's more on here. Yeah, and then for now, we're not going to do any of these on our graphs. We will do those tomorrow. And then we're going to look at these. So the center, the dilation centered at 0 with a scale factor of 3. OA is 6. OB is 7, and AB is 8. So we need to find A prime, B prime. We basically need to find the scale factor. So we know if this is 7, and it says it's a scale factor of 3. So the whole thing is going to be 3 times 7. So the whole thing is 21. So we know O to B prime is 21. Then we can do the same thing down here. And we know that this whole thing is going to be 18. So OA prime is 18. Now we need to find the missing parts here, like B to B prime. Well, if I know the whole thing is 21, and this part is 7, I can do 21 minus 7, and I get 14. And then here, A to A prime, I know the whole thing is 18, and this part is 6, so I can do 18 minus 6, and I get that it's 12. And then I have to find A prime to B prime. So what I need to do there is I need to do a scale factor of 3. If this was 8, I just do it times 3, so it should be 24. So 24, 21, 18, 12, 14. And that is all for this part of notes 1. Oh, no, we have more. One more thing. Same thing as we did last time. Dilation in the center is 1/2 this time, so it's getting smaller. You know that the whole thing is 8. So if we want just O to B prime, that's going to be 4, because it's half of it. And then, so if the whole thing was 6, this is going to be 3. And then A to A prime, well, we know the whole thing's 6, so this part's 3. B to B prime, we know the whole thing's 8, this part is 4. And then if this, it tells us that AB is 4, so if this is half, it would be 2. So 2, 4, 3, 3, 4. Then next it says, find the scale factor, tell whether it's a reduction or enlargement. So we are going to compare our sides. Remember, we do P prime over P. So we would have 12.5 over 5. And then we also know, so we can say that that is an enlargement because that is bigger than 1. And then if we do over here, we know that this little in part is 7 and this outside part is 12. So our P prime, or we would have 7 over 12. And then we know that X is over 18. So we can cross multiply and we would get 18 times 7, 6, 5, 126 equals 12x. So 126 divided by 12 goes in there once, 0. So it'll be 10.5. And it was 7 over 12, so it was a reduction. And if I didn't solve for x on this. Oh, you guys didn't see that. It was 7 over 12 and we set it equal to x over 8 and cross multiplied and got 126 equals 12x. Then divided by 12 and got x is equal to 10.5. And that is all for that one. And then that is the end. Notes 2 start there.